Today we're going to talk about graphing functions, quadratic functions in the form of f of x equals ax squared. So if we think about this chapter and relate it to last chapter we were solving the quadratic functions by using factoring. This chapter you're going to be graphing them, and we'll actually talk about where a lot of those solutions end up showing up on your graph. So anyway, to begin with, I want you to look at page 245. Okay, and I want you to complete exploration 1 with your groupies. Okay, here you go. For those of you struggling on this, one way of doing it is just quickly create an XY table. And please note that one of the things that we do when we graph quadratics is we use a formula that that helps you to find its line of reflection. So if you just focus in on part A here and you focus in on the quadratic, there's a line that runs right down the middle of this. It'll be right in here. Actually, you know what? Use a highlighter for it. That line right there, I know it's the y-axis, but that's also, in this case, the axis of symmetry. The axis of symmetry actually reflects points from one side of the quadratic to the other side. They're the same distance away on those quadratics. Okay? So one thing that we would like to do is always to know where that axis of symmetry is. All right? So our axis of symmetry, which we will call AOS. So if we write that up here, the axis of symmetry is always located at x equals negative b, or opposite of b, over 2 times a. Now for those of you who are like, fantastic, the next question usually comes up is like, what are a and b? Well, a and b, you have to actually know that in a quadratic in the form of, let's write it right here, in standard form we call it y equals a times x squared plus b times x plus c. So if you think back to last chapter, we had those quadratics. We had this format, and the thing that's attached to the x squared is called our a term. So in this, our a term is 1. Okay? So if I was completing this equation here, it would be the opposite of b over 2 times a, and a is 1. Well, what is b? What's attached to x? Yeah, 0. There's no x. Right? It's 0x. Okay? So that's 0. Well, what's negative 0 is just 0. There's no such thing as negative 0. So 0 divided by 2 is 0. Anytime you have 0 over the fraction bar, the answer is 0. Okay? That's why this axis of symmetry is on this line. It's on the line x equals 0. If I was cruising down the x-axis, right here is 0. That's that line. It also happens to be my starting point in my table. I'm going to plug in 0 right there. And when I put 0 in for x squared, I get 0 out. That's how they get that point. That point right there is called your vertex. So these are all terms that we want to get down. That's our vertex. That's our axis of symmetry. The x-coordinate of your vertex and the axis of symmetry are always the same. Okay? So when we get x equals 0 there, that goes in right there. And what that allows you to do then is allows you to build your table. Well, we don't really need to build a table for this, x squared. We need to build a table for this one, 3x squared. Okay? So if I'm doing the opposite of b over 2a for this equation, which one of the things change on here? B doesn't change, right? But a changes. But does it change? Now I have 0 over 6. Does it change that? No, it's still 0. So it's still going to start at the same spot. It's just now when I plug in things, let's say like they have 1, 1, and negative 1, 1. Let's plug in 1. If I put 1 in for x here, well, I have to square it first. What's 1 squared? 1 times 3? 3. It's 1. It's not 1 anymore. It's 1, 3. If I put 2 in, I get 2 squared, yeah, times 3 is 12. Well, that is now there, and it's actually way up there. Okay, so I have a half of my parabola. What happened to it? What if you compared this to this? All right, well, let's see the other part of it. How would I get this point? How would I find the other point? Yeah. Negative 1, positive 3, though. Yeah, you just reflect it over. Reflect it over. You could calculate it. You could put negative 1 in, but negative 1 times negative 1 is 1, times 3 is 3. And when I put negative 2 in, negative 2 times negative 2 is 4, times 3 is 12. It's quicker just to reflect the points. All right, so if I go ahead and draw that in, what has happened to my parabola? That's the name of this U-shaped thing. Yeah. Yeah, it gets steeper. Some people think of it, it gets skinnier. Okay, let's just focus in on this point to this point. Okay, which one's further from the x-axis? Yeah, the second one. Okay, how much further? This has a length of 1. This has a length of 3. Okay, what about this point and this point? How far is that? From x? That's 4. How far is this? Come on, stay with me. I'm actually challenging you guys to think a bit here. That's 4. How far is this one? It's 12. Okay, this one's 4 away. This one is 12 away. This one is 1 away. This one is 3 away. How are those numbers related? If you're going from 1 to 3, and then 4 to 12, how am I getting there? Yeah. Yeah, multiplying by 3. These points are going up 3 times as fast. So if I know that this one is at 9, tell your neighbor where the point would be for the next one if I was graphing it on this line. Yeah. 9 times 3, right? 27. It's going up 3 times as fast. This term right here, this A term, is considered our speed, the speed of our graph. It's how quickly our graph's going up. This graph has a speed of 1. It's accelerating from the x-axis at a speed of 1. This graph is accelerating away from the x-axis at a speed of 3. This graph's going to accelerate at a speed of negative 5. Now we'll talk about what negative does here in a minute. This graph's going to speed up at 1/10. Tell your neighbor what this graph's going to look like in compared to this one. Hey, that's what it looks like. What happened to it? It got fatter. It's going up slower. Okay? So where we were at 1/1, we're now at 1/10. Okay? It's like you and your buddy racing. Your buddy's like cruising up around the track and you're walking. Or vice versa. Maybe you're cruising. They're walking. Okay? All right. You guys, we call these things, stay with me now. This right here is called a vertical stretch. That is a vertical stretch. Okay, tell your neighbor why we would call that a stretch. What are you stretching, and where are you stretching from? Okay, what are we stretching? Say, what are we stretching? We're stretching the length of the graph away from the what? Where are we stretching it away from? Yeah. We're stretching away from 0, which in this case is our x-axis. Okay, you guys, please make a note of that. I'm really trying to set you up for success in advanced algebra. Chapter 1 is one of the toughest chapters when you get to second-year algebra, and it's because of these vertical stretches and shrinks. Okay? That other graph that we had, that I put up there, this one right there, that is a vertical shrink. That means this point has now compressed. It's gotten shorter. It's gotten closer to x. This one got closer to x. This one got closer to x. They are shrinking towards. It's like you're taking it and smushing down on it. Yeah. Yeah, well, if you're comparing at x equals 1, this point's closer than that point. That's why we say that. That's why we call it a vertical shrink by a factor of 1/10. And the 1/10 comes from right there. Okay? When we go through and put a negative out in front, it flips our graph upside down. So our point that was at, in this case, notice that one is at -2, +4. That one's at 2, 4. Well, those points, if this is a 5, if you were 4 units away, and that's 5, how many units should it be now? Originally it was 4. We stretched it by a factor of 5. It's 4 times 5. 20. Should be 20 units away. Well, it is. It's 20 units away, but it's 20 units this way. Yeah. It's down at -20 because of that negative symbol. The negative symbol just means it flips it upside down. It's a reflection in the x-axis. Okay? So things that we want to focus in on. Okay, about our A term. Let's go ahead and summarize that stuff. All right? So if you take a look at this, if you take a look at page 246 here, what are some characteristics of the graph of a quadratic function and y equals ax squared? Well, tell your neighbor what it looks like, how you can find one side and find the other, how all that relates. Go ahead and summarize on number 2 there. Okay, what shape are they? Yeah. A parabola. They are U-shaped. Okay, we call it a parabola. Could be opening up, it could be opening down. All right? What do we know? Well, we know that this point right here is called a vertex. We also know that there's a line running right down the middle of your parabola called a axis of symmetry. We're going to call that the AOS. It's always in the form x equals. Okay? Yep. X equals opposite of b over 2a. Because negative b is read as the opposite of b. So if we plugged in a negative there, it'd become positive. Okay, this next question, number 3, says, how does the value of a affect the graph? Okay, now let's ignore this statement for a minute. And that. Let's just focus in on this. How does a affect our graph? Tell your neighbor what it does. All right. What happens if a is negative? It flips. It reflects in the x-axis. It opens down. Okay, reflect in x-axis. Make sure you know that term. Reflect in the x-axis. Okay, what happens if it's positive? Sarah? Oh, you're getting a little ahead there. Positive just opens up. But then if A is, what happens if A is further from 0? What happens the further A travels away from 0? Brian? It gets skinnier. It goes up faster. We call that what type of? We call that a vertical stretch. What if it's closer to 0? Closer A gets to 0, we call it a vertical compression or a vertical shrink. This book will call it a shrink. A lot of books call it a compression. Okay? So the closer A is to 0, the wider the graph. It's a vertical shrink. The further it is from 0, the narrower the graph. We call it a vertical stretch. And we're going to study all the A's, the B's, and the C's that we saw. Okay? This other stuff that they said right here, I mean, really, we've considered that. We've just considered it without considering it the way they wanted us to. Okay. Any questions there? Okay, so with that being said, I want you to now turn to the next page of your student journal. Okay, page 248 of your student journal. 247 actually kind of goes through everything we just went through. The only thing, actually, let me pause on 247 for a minute. The one thing that we didn't talk about is decreasing and increasing. Here, this parabola is decreasing. It's decreasing. We measure it all by the x-axis here. So if I want to talk about decreasing and increasing, if I'm looking at that as a measuring stick, this parabola is decreasing when x is, it's when it's less than 0. So it's decreasing when x is less than 0. You may want to add that there. When is it increasing? Yeah, when x is greater than 0. So some of us will say, well, when it's positives, it's increasing. When it's negatives, it's decreasing. But you want to use this terminology because it's not always 0. I mean, if the parabola is over here, then it might be it's increasing at 4 and decreasing when x is less than 4. Yeah. Yeah. Still you're measuring it based on here. So on this side, your graph's falling. As soon as you get to here, it's rising. And it doesn't matter. The vertex could be right here. The parabola we could be looking at is this one. Okay, it's still increasing when x is less than 0, or decreasing when x is less than 0. Okay, because we're using this as our measuring stick. And then it's increasing when x is greater than 0. Okay. All right, that is called our parent function, by the way, y equals x squared. And I'll explain how we graph that here in a minute. Okay, but everything starts at this. Right now the speed limit of this is? It's 1. That's the speed of that graph. That's the parent function. If you get smaller than 1, it's wider. If it gets bigger than 1, it's narrower. Okay. At the top of the next page, there's some more information just summarizing what we talked about, just in more of a math-ease way, if you like math-ease. Okay? I do want you to look at the extra practice, number 1 and 2 on the bottom, page 248. Go ahead and work on those two problems with your groupie there. Talk about the vertex, axis of symmetry, increasing, decreasing. Okay? Domain range. I'm not asking you to graph them, right? We're just going to identify characteristics. So, if we go like, tell me where the vertex is. Tell me where the axis of symmetry is. Start with those two things. Okay? We'll move on from there. We'll ask where the domain is. But for right now, get those first two. and the range. Let me help you out with what I'm expecting here. Make sure you take good notes on it. My vertex is what I'm looking for. So characteristics, what's the vertex? -1 what? -1, 1. It's just the vertex. It's a coordinate. Okay? What's the axis of symmetry? X equals, that's this line, -1. It's always the same as this. These two things, make a note to yourself, they're always the same. Okay? What's my domain? Domain means when does it not exist for X? Well, these arrows mean it keeps expanding outward forever, right? So that means all real numbers. Now, have we talked about that symbol in here?
Yeah.
Yeah, remember, it's cool R. All real numbers. It looks cool. You get shaved in the back of your head, dude. Be sweet. It'd be all real cribs. Okay. Okay, we got range. Range is where it exists on Y. It starts existing right here, right? So where is that crossing the Y-axis? At 1. Okay, it's crossing at 1. So it's at 1 and it's getting bigger. It's going upward from 1. So it's Y is greater than 1. Can it be equal to 1? Does it actually hit that line? Yeah, it does. So Y is greater than or equal to 1. Those are some of the characteristics. Any other characteristics? When's it increasing? And when's it decreasing? It's decreasing until you get to X equals -1. The same point right here, by the way. It's decreasing when X is less than -1. It's increasing when X is greater than -1. So it goes down until you hit this line, and it goes back up. That line happens to be at -1. Those are the characteristics. So I want you to do the same characteristics on number 2. Describe the vertex. Describe the axis of symmetry. Oops, it's not a coordinate. Describe the domain and the range. Okay, go ahead and share your answers with your neighbor if you haven't already done so. Range starts at 4 and it goes downward. How many got that for your range? Well done. Right here. It falls. Or decreases. Well, it's decreasing actually on this side of the axis of symmetry. So it's decreasing when X is when it's greater than 3. Yeah. So on this side of the line of 3, it's decreasing. And it's increasing on the other side. Cool? All right. Yep. Okay. Hey, we're going to try to graph some of these. Okay? Let me explain some characteristics of these graphs. Graph the function, compare it to y equals x squared, or f of x equals x squared. So let's start with this first one. And on this first one, we're going to actually graph both lines, or both curves. Okay, we're going to graph starting right here. I know that just from what I've seen so far, that when I'm trying to find A, B, and C, in this case A equals, if I'm graphing y equals x squared, A would be what? It's 1. It's a number in front. What's B?
0.
Everyone understand why it's 0? Remember, it's ax squared plus bx plus c. What's c? 0. Anytime b is 0, and we do opposite of b over 2a, we get 0. Okay, because b is 0. It doesn't matter what we put down here. It won't matter. We get 0 out. So that means we're always starting at x equals 0. And then when I put 0 in for x, I get, excuse me, right here, I get 0 out. So my vertex is at 0, 0. Question? No, I'm looking at this function. Yeah. So maybe I should have put that up here with that one. Okay, so I'm just kind of focusing on the parent function. A equals 1, B equals 0, and C equals 0. Okay, and on the parent function, if I do the opposite of B over 2A, I get 0 over 2, which is still 0. And so if I plug that in, my vertex is going to be 0, 0. Okay, we always want to find the axis of symmetry. We want to find A, B, and C, and we want to find the vertex. Okay, so now we know for x squared, that's it. Yeah?
So when b is not 0,
Then we will deal with that. B be a big problem. So we deal with B like on the 4th day of graphing. Right now we're going to introduce you to A, then C, and then A, B, and C together. All right, so right now we're just dealing with A today. So anytime you just have A, B is going to be 0, which means your axis of symmetry is always going to be right here. All right. So here's how you graph these. If I have x squared, I'm not graphing 5x squared yet. I'm graphing this one. When x is 1, what's what? Come on, man. Say what? It's 1, right? Okay. When x is 2, what's y? Come on, man. What is it? It's 4. When x is 3, what's y? It won't fit, but when x is 4, what's y? 1, 4, 9, 16. What are we counting by? Come on, what are these numbers? They are perfect squares. Right? Okay? Hey, so I've got this graph. Here's my parent function. All right, it's just the graphs of all the perfect squares there, and then their reflections on this side. Cruising down. That's our parent function. Now, if I were to kind of outline that in maybe in this color, just so we don't get it confused with the actual thing that we're supposed to graph here, and compare it. Hey, what's this graph going to do? What do we know about the 5 compared to the 1? It's going to stretch. So when x is 1, what's y? It's 5. Just so you know, once you find the vertex, that is always true. So like if I look at this next graph, right over here, negative 4x squared, and I just draw my axes here. Just so I could hopefully get you to relate this, I will tell you the vertex of this graph is still at 0, 0. In fact, the vertex of all your graphs today will be at 0, 0. Okay? What is, when x is 1, what is y? You shouldn't have to do any math. It's going to be what? It's not 4. It's negative 4. Which means its reflection is there. So if I'm graphing this next one, it should be this fast. It's at 0, 0. That's our vertex. When x is 1, what's y? Negative 7. It's your A term. That is always true in a quadratic. Whatever your A term is, you plug that in, that's going to tell you how far you go up or down from your vertex when you're 1 unit away. Okay? So if you can find the vertex and you know the A term, you know 2 more points automatically. Okay? Yes? 2 is not a perfect square. Be 1 times 1, yeah. Hey, so on this one right here, tell your neighbor where your first point would be after the vertex. Good, at negative 1, right? It's your A term. On this one right here, tell your neighbor where your vertex would be. Careful, I changed up the question. Vertex. 0, 0. Now tell your neighbor where your first point would be. 1, negative 1/5. Like right there. So that's why it starts getting so wide. Your graph starts doing this. It gets really wide. Okay? Yeah, too much McDonald's. All right. Hey, we got it? That's what we're looking at here. Okay. So, your assignment today. Your assignment. I want you to answer these 2 questions. 9 and 10 right now. And that's not it. Okay? And you're going to have a puzzle time that you're going to work on. Okay? I want to make sure you get those 2 answered there.